There are so many different types of limits for which we can find the sequence, and here's another. This is the sequence defined as the square root of n squared plus 5n minus n. And the reason I put this in here is that this is an infinity minus infinity type of definition. I know that many people look at that and say, well, what do you mean? Isn't infinity minus infinity the same thing as 5 minus 5, which is 0? So isn't this going to equal 0? And the answer is no, it's not. Infinity minus infinity is an indeterminate form that has to be evaluated the same, just like 0 over 0 or infinity over infinity or 1 to the infinity. These are all indeterminate forms. So in order to evaluate this, what we're going to do is we're going to set up the limit. We know that the only type of limit of a sequence is its limit as n approaches infinity. So this is going to be square root of n squared plus 5n. What I'm going to do is multiply it by the conjugate over the conjugate. So, oops, sorry, n squared plus 5n minus n. That's what we're trying to find the limit of. I'm going to multiply this by conjugate over conjugate. So this is n squared plus 5n plus n over n squared plus 5n plus n. And this is, of course, going to be over 1. Just so I can multiply fractions, and putting this term over 1 doesn't change anything. So multiplying that out, I get limit as n approaches infinity of n squared plus 5n. That's the square of the square root of n squared plus 5n minus n squared. Recall that when you multiply conjugates, you just get the difference of squares. And this is going to be over the square root of n squared plus 5n plus n. That equals this limit, which is going to be 5n over, because these cancel, and that's going to be n squared plus 5n plus n. So to evaluate this, what I want to do is multiply it by 1 over n over 1 over n. And that's going to give us the limit as n approaches infinity of, we can easily see that on top that comes out to 5. Down here, this is going to be square root of 1, well, let me do it in another step. Let's do 1 over n times the square root of n squared plus 5n plus 1 over n times n. We can easily see that this second part of the denominator is just going to be 1, so that's going to be 1 here. This we're going to evaluate as this 1 over n times the square root. We're going to evaluate this way. We're going to treat that as the square root of 1 over n squared, which is the same thing as 1 over n as long as n is positive, times the square root of n squared plus 5n. And then, of course, we still have a plus 1 here, which is not under that radical sign. So this now comes out to the limit as n approaches infinity of 5 over, this is going to be the square root of 1 plus 5n over n squared gives us 5 over n, and then plus 1. We can see that this, as n approaches infinity, this is of course going to approach 0. So this just becomes 5 over the square root of 1 plus 0 plus 1. Simplify that, and that becomes 5 halves. So that's the limit of this sequence.